We have two variables, x and y, such that x to the fourth times y to the fifth equals 1, and we have to find the logarithm of x to the fifth times y to the fourth base x. So in a problem like this, maybe we can take the given equation and try taking the log of both sides for it. Now, what base are we going to use? Well, since we're trying to find log base x of x to the fifth times y to the fourth, maybe it would be good to take the log base x on both sides of this equation right here. So let's do that. So the log base x of x to the fourth times y to the fifth, well, let me just write it down real quick. Log base x of x to the fourth times y to the fifth. Well, the first thing we can do, and again, this is just the left-hand side, is we can split this logarithm up into two parts since x to the fourth and y to the fifth are multiplied by each other. And there's a log property that if you have two terms inside a logarithm and they're getting multiplied by each other, they can be split into two logarithms. So we can rewrite this as the logarithm base x of x to the fourth plus the logarithm base x of y to the fifth. So this line right here is equivalent to this line right here. And there's one more thing we can do. It's that if we have an exponent like this 4 over here and this 5 over here, we can take it out of the logarithm and keep it as a coefficient in front of the logarithm. So we can rewrite both of these logarithms as 4 times log base x of x. Again, we just took this exponent and put it in front, and then plus 5 log base x of y. And we're almost done. Log base x of x is just 1. If the base and the actual value that you're trying to take the log of are the same, that will just cancel out and you're just equaling 1 over here. So it's 4 times 1, or 4. And this still stays the same. It's plus 5 log base x of y. And so this is the left-hand side. What about the right-hand side? Well, taking the logarithm of 1, no matter the base, is always going to get you 0. So this is equal to 0. So you have 4 plus 5 times the log base x of y equals 0. And we can subtract 4 and then divide by 5 to get log base x of y equals minus 4 over 5. So we have this right here. So we have pretty much taken this equation and turned it into this right here. So for now, let's just leave this equation be. We pretty much simplified it into this form right here. Now let's just take the existing equation that we already worked on. Let's just try to work on it a little bit more and see if we can get more forms out of it. X to the fourth times y to the fifth equals 1. As you can see in this expression right here, we want y to the fourth, not y to the fifth. So let's see if we can try to set y to the fourth all equal to itself in this equation, and then plug that back into here. So what I mean by that is, let's divide by x to the fourth times y on both sides. That way you have y to the fourth left over here, and you have 1 divided by x to the fifth times y over here. So again, all we did was, not x to the fifth, x to the fourth. So all we did was divide by x to the fourth times y on both sides. So let's plug this expression in, 1 divided by x to the fourth times y, back into the expression that we're trying to solve. So log base x of x to the fifth stays the same, but y to the fourth can now be rewritten as 1 divided by x to the fourth times y. Okay, so now things can be simplified from here. The x to the fifth and x to the fourth turns into just an x. So now you get log base x divided by y. And now we're just trying to solve this expression right here. Well, since you have a fraction over here, you can split it into log base x of x minus log base x of y. In other words, log base x of x minus log base x of y. Log base x of x, again, if the base and the expression you're taking the log of are the same, that just simplifies to 1. And then log base x of y is just negative 4/5. It's what we found over here. So we can plug that in. So minus negative 4/5. And now our answer is just 1 minus -4/5, or 1 plus 4/5, or 9/5. That is our answer, and we are done.